Welcome all of you to the fourth session, the AI Transformative Opportunities and Challenges panel within the Science for Life Symposium today. Welcome all of you. Thank you so much. Ladies and gentlemen, VIN Future Prize is an international prize to honor outstanding scientific achievements and promote innovations for humanity with the participation of the world's leading scientists, policymakers, leaders of technology corporations, and the prize laureates, to disseminate scientific and technological knowledge to the public and connect generations of young scientists, inventors, and entrepreneurs with globally established inventors for potential partnerships. And this event is held with the participation of 4 distinguished speakers who have excellent expertise and experience in the field of artificial intelligence. And to come to this event today, we would love to extend our warm welcome to our distinguished guests. Let us welcome Dr. Lê Thái Hà, Managing Director of VIN Future Foundation. Welcome, Madam. We are honored to have Professor Sir Richard Henry Friend from University of Cambridge, Chair of the VIN Future Prize Council. Welcome, sir. And we are honored to have Dr. Sui Dong Huang, Zoom Video Communications, member of VIN Future Prize Council, and also the chair of the symposium today. And last but not least, let us welcome Mr. Chen Anh Tu, Deputy Chief of Department of High Technology, Ministry of Science and Technology. Welcome, sir. And now I would love to focus your attention to the screen for the introduction video about the topic today, and we will know who we're going to be with in the panel discussion. Video, please.
The world as we know it is now reigned supreme by artificial intelligence. As AI models reach an unprecedented level of efficiency, the globe is captivated by the impact of this technology on all aspects of life. According to estimates, the global AI market is poised to soar from $241.8 billion in 2023 to $740 billion in 2030. But the implications of AI reach far beyond economic potential. This is the technology that redefines the fabric of our existence, from the employment landscape to groundbreaking academic research and even the healthcare revolution. Along this journey leveraging the power AI, many policies will need to be developed and implemented to ensure AI's transparency and equitable access to innovations around the world. To explore further on these interesting topics relating to AI innovations and developmental strategies, VIN Future Foundation proudly brings to you the Artificial Intelligence Transformative Opportunities and Challenges Symposium during the VIN Future SciTech Week. The chair of the symposium is Dr. Shudong Huang, Chief Technology Officer at Zoom Video Communications. Also joining the symposium are esteemed panelists who are prominent figures in AI and computer science from academia and industry, including Dr. Padmana Vananundan, founder of AI Matters for Development, Dr. Hung Bui, CEO of Vian AI, top 20 global companies for leading AI research in 2022, and Professor Leslie Gabriel Valiant, Harvard University and laureate of the A.M. Turing Award in 2010, under the theme Boundless Unity of the VIN Future Prize Award Ceremony 2023. Join us for a symposium like no other, where brilliant minds come together to address the challenges and opportunities that AI brings to humanity.
Thank you so much, distinguished guests, ladies and gentlemen, for your attention on the video clip. And now, to commence today's symposium, I would love to invite to the stage Dr. Sui Dong Huang, Chief Technology Officer at Zoom Video Communications and member of the VIN Future Prize Council, and also the chair of today's symposium, to deliver the opening speech. Doctor, please. And now is your time. Thank you.
Thank you very much. Welcome. This is the best time, as the title indicates. Transformative opportunity is just so close to all of us. So it's my great honor to have this opportunity to have this in-depth discussion with all of you. So before we start, I want to share with you one slide. Can you move to that slide? So we need AI to move the slide forward. Oh. Okay. We got it. So I want to use this slide to illustrate the history of the last 1,000 years. Our society, in terms of global GDP, that's good metrics about productivity. What has been driving that amazing growth? As you can see, before printing press was invented by Gutenberg, it was very slow but gradual growth for the world GDP. Gutenberg printing press brought Europe out of the Dark Age. Since then, the growth was getting better, but it was not until British invented the steam engine. You can see a more dramatic growth. Then is one industrial revolution, technology breakthrough after another. The growth is increasing in exponential way. Now, this is the time. We are witnessing the historical moment. The productivity for the global growth is going to be accelerating. That's why we are having this symposium. It's also, I believe, a leveling paradigm shift opportunity for all the nations, whether you are developing countries or developed nations. If you can embrace this paradigm shift opportunity, all of us, whether it's a small company or large enterprises, we have the opportunity to reinvent ourselves. So it's my great pleasure to invite Professor Lalonde from Harvard to explain to us why this is growing like this behind that AI technology and the background. Welcome, Professor.
Okay, well, thank you very much for the invitation, and I look forward to this panel discussion. So I want to give just a very brief background on, I suppose, the science of AI. But besides the substance, clearly one other topic which is always worth discussing with AI is public understanding, because now, rather uniquely among technologies, every person has access to a state-of-the-art AI system, which is unusual. And also the way this has been rolled out in the last 12 months is rather extraordinary in that there's been quite a lot of confusion about how seriously you should take this advance. So I suppose every historical discussion of AI has to start with Alan Turing, and he asked very fundamental questions like, can every task done by humans be also done by a machine? And in particular, in a radio broadcast, he said that it is customary in a talk or article on this subject to offer a grain of comfort in the form of a statement that some particularly human characteristic could never be imitated by a machine. I cannot offer any such comfort, for I believe that no such bounds can be set. So this was already in 1951 when computers essentially, as we know them, didn't quite exist yet. And the main reason I bring this up is that this wasn't just his personal opinion, but this is like established science that he could deduce this from a principle of computer science, the Church-Turing thesis, that which says that everything we think of as a mechanical computation, any medium in the physical world, can also be done by a computer. So, although some people need some discussion for this, I think we should accept this as settled science. So this isn't a fruitful subject of discussion anymore. But of course, progress followed rather slowly after this, and the reason is that two things he left out. One is to characterize what it is that humans are capable of. And once you have some characterization, then you want some algorithms to realize them. So I think all progress since then is of this form that you need algorithms to do things, but before you have an algorithm, you also have to say what you're going to achieve. And as far as these capabilities, so people tried various things. So for example, one capability is mental search, and that was good enough to build systems to beat the world chess champion, but it didn't generalize. So it's not a characteristic, a capability which does more general cognitive functions. So other capabilities were based on mathematical logic, and yet others on Bayesian inference. And again, these have their place, but they didn't lead to the advances which are most praised today. So the systems which have become famous now and influential are essentially based on a different capability, and this I would describe as learning from examples. And here the phenomenon is that we can generalize from examples, see what commonality they have, and even more amazingly, we can do this efficiently. So humans can learn words in their languages they hear and can generalize correctly. Okay, so what this phenomenon is very simple, as we know. So you get some training examples with their labels. So maybe you get examples of pictures of elephants labeled as elephants, and pictures of other things labeled as different things. And you run it through a learning algorithm, of which deep learning is a famous current example. And out comes a classifier, which is really a program to further classify examples. And then once you have a classifier, then you can classify new examples for which you don't have the labels. Okay, so with this classifier, you can get new examples, and you can tell whether they're examples of elephants or not. And so basically, this scheme is the one which powers large language models and all the other systems we see now, which do impressive human-like behavior. And it is a kind of a very powerful phenomenon, especially if you scale it up. And so, but what I want to emphasize today is that we understand something about this, and there are also some limitations that we can understand. It's not just magic. We can characterize roughly what we're getting. So it's a very powerful phenomenon, but certainly one restriction you need is that the text examples you're going to classify have somehow got to come from the same world or probability distribution as the training examples. If the world has totally changed, you can't hope that what you've learned will be useful. And the second one, which is maybe what really powers this, is that when this works, there's something efficient about it. That if you make more of an effort, you collect a bigger data set, you do more computation, then you can predict more accurately. And furthermore, the improvements you get from doing the more and more work are big enough that it's worth doing. Okay, so this basically says that the prediction error goes down as algebraically as some fixed power of the effort you make. And the effort n here is the number of computational steps you make, and also includes the number of examples. but all the time you get these algebraic curves, which mean that to get a fixed fractional reduction in your prediction error, you will only have to make some different fixed fractional increase in the effort. So this is very powerful, because when people spend $1 million on training something and they see that, well, if only we could spend $10 million, we get a better accuracy, then they will indeed do this. So now we're in this race where people are willing to spend more and more resources into training bigger and bigger sets, or even training on the same set for longer and longer. So in all this, an important factor is that you need to have a good set of training examples. For this to be useful, you have to have a clean set of training examples. And so, for example, the fact that large language models are so interesting is that if you're interested in, say, well-formed sentences, a language which is widely used, like English, then for hundreds of years, people have written nicely constructed sentences, and you can just feed this in. So it's easy to get a very large training set for natural language. And that's why these systems are able to come out with rather nice continuous sentences. Okay, so this is called the probably approximately correct model technically, but the reason why I think this phrase is worth knowing, even if you don't care about the mathematical aspect, is that the promise of this kind of generalization is probabilistic. So for any one example, the guarantee that something classified as an elephant will really be an elephant is a kind of a probabilistic claim. So if you have an application which is where it's a life and death situation, you have to make a critical decision, then there are some issues. So for example, the fact that driverless cars aren't as easy to make as people one time thought is not hard to explain. Okay. So as far as limitations of this, so if you just train using this paradigm, then both in theory and in practice, many things are not promised, which you may want. And among the many things people may want, so one is some real guarantee that a single classification, some important decision you make is well predicted. So explainability, that you get a good explanation of why this recommendation you should follow. The third one is security issue, that especially in vision, it's very easy to fool a trained neural net to misrecognize a concept by putting in an adversarially constructed example. So lifelong learning, the idea that you shouldn't have to retrain the whole net every time you want to put in a small amount of knowledge. Reasoning. So none of these are promised by the basic learning by example paradigm. And for example, in large language models, none of this is promised. Of course, since the investment in large language models is so enormous, people are looking to find whether in fact any of these things are provided by accident. Okay, thank you.
Thank you so much, Professor Leslie Valiant, for your impactful presentation about the background to current AI. And now it's time for us to welcome back to stage Dr. Sui-Dong Huang. So he is also the chair of the symposium today, and he will deliver the second presentation about the limitless human connections via federated AI. So Doctor, the stage is yours. Thank you.
Thank you. Thank you, Professor Valiant. That's a wonderful summary from academic point of view, where the current AI model got its limitation. So now I want to talk about, from the industrial production AI point of view, where we stand. So I want to emphasize the human connection aspect. We're all social animals. I left Microsoft 7 months ago to join Zoom because I believe that is the best company on this planet to connect people. It's a verb, no matter where you go, and people understand what it means as a verb to connect people. I believe the AI reached the stage to really transform how we connect, how we collaborate, how we communicate. So all of us can be better citizens as a result of this AI revolution. I want to reflect what we were trying to do to create that census. So in Microsoft, more than 3 years ago, I published a blog called XYZ Code. I really want to emphasize we need to jointly optimize 3 dimensions. Language, of course, is very important. Text, that's X dimension. And we are different from animals because we have the language. That is the symbol of intelligence. Then the second dimension is multilingual aspect. On this planet, there are 7,000 languages spoken today. 7,000. If you have all the AI companies combined, we cover less than 10% of the spoken language. So if you want to have that global view, that multilingual aspect is very important. The third one is why. I know this is not the standard math order. I got X, Z, Y. Is our senses, both video and audio. So that joint intersection is going to be the foundation for AI. In that context, in the summer and at CASP, I gave my perspective talk about the architecture of tomorrow. I used the same slide. My hypothesis is the large language model, that is the big component, LLM, is going to be the orchestrator to unify X, Y, Z. You can have different encoder, it's speech encoder, or video encoder, or joint encoder. Then they will be unified through the large language model. With the instruction, a grounding of external knowledge through RAG retrieval, you can have the best AI outcome that can be as impressive as it seems to be, including the challenge Professor Vaillant talked about. So just a few weeks ago, I'm very happy Google put that architecture into production. It's the first of its kind, native, multilingual, multimodal, large language model, orchestrated AI model, Gemini Ultra. I'm very happy that I was intrigued. The architecture is available in form of production for people to consume. So I talked about in the introduction why AI is going to really change the global GDP. Here, I want to share with you the older news. You look at this legal subject exam, right? If you want to be a lawyer, you have to really reason very well. Otherwise, you cannot even defend your client, right? So one way to judge whether you're a good candidate to be a law school student or whether you are going to be a good lawyer to articulate, to argue, is to take that exam. On the right column, you see the average score of people like you and me. It's around 68. So all the older AIs, such as GPT 3.5, ChatGPT, they were much worse than humans. until GPT-4 came out, had outperformed you and me. What does that mean? In Vietnam, like in a lot of Asian countries, in China, for example, started from the Sui dynasty. The emperor decided who can be the prime minister of the country by taking the national exam. If you are able to really have a good score, you have the potential to be intelligent, to govern the country. So that's the ultimate test of intelligence and the capability. Unfortunately, today, none of us can compete on the exam, including the medical exam, SAT in the US, AP test, MCAT. Computer outperformed all of us already. So that was the GPT-4 from OpenAI. Google, with the Gemini Ultra, is not available yet, outperformed the GPT-4 by a big margin, whether it's on the language, or video understanding, or speech recognition, because it's a native AI production model. So, not many companies can produce foundation model like Microsoft, OpenAI, or Google. Even a bigger company such as Boeing, they can produce the airplane such as 787 by themselves. They federated different components of the airplane you're flying to get to Vietnam, whether it's from Japan, Italy, US, or Europe. So they did a very good job. So as AI foundation model is ready, to all of us, the challenge is how do you apply those foundation model for your workloads, for your scenario? Zoom is one of such a company. We are interested in having the best communication solution, but we are not an AI foundation company. So we approached AI by using federated approach, just like a Boeing. I shared a blog just a few weeks ago. Essentially, I want to proudly tell you, by federating different models from OpenAI, Anthropic, Meta, etc., we achieved 99% AI quality with less than 6% of the inference cost. I wanted you to take a moment to think. By massage all the existing good models out there, we can deliver cost-effective solution to go to market. This is all in production. If you're using Zoom AI Companion, after each meeting, including Vietnamese, you have the meeting minutes. You have the next step. You have the new future advice about what you should or you cannot do. This is almost like in the Chinese, I have to use this Chinese story. I give a talk in Singapore. I said, well, in Chinese traditional story, everyone is familiar. If you have 3 stinky shoes repair people, if you can orchestrate them well, they will be as smart as the smartest person in the history of China. His name is Zhuge Liang. So that's the approach Zoom took. We combined 3 stinky large language models together, created something cost-effective. It's not as good as the best you can do, but it was very close. So I want to actually just close this with a video, how AI Companion can help you catch up with a meeting. You can be distracted in a meeting because AI Companion is watching, listening on your behalf. They will tell you what who said what you should actually pay attention. Can you play the video? Go back. Yeah. So that's it. Thank you very much.
Thank you so much, Dr. Sui Dong Huang. I really appreciate it, and I really do it a lot with my job with the Zoom platform. Thank you so much for your presentation. And would you please remain on the stage for the chair of the panel discussion today? Would you please? And now it's time for the second part, the panel discussion. And I would love to welcome back to the stage Professor Leslie Valiant to be on the stage. And we would love to welcome two distinguished panelists today in the panel discussion. Please welcome on the stage Dr. Padmanabhan Anandan, founder of AI Matters for Development and member of the Win Future Prize Council. Please give a round of applause for the Dr. Padmanabhan Anandan. Thank you. Welcome, sir. And now, let us welcome Dr. Bùi Hải Hưng, founder and the Chief Executive Officer of Win AI Vietnam, top 20 global companies for leading AI research in 2022. Welcome, sir. And now it's time for us to start the panel discussion today with the moderator, Dr. Sui Dong Huang. It's your time. Thank you.
Thank you. All right. Now we're going to have fun. I'm not going to follow the script, okay? I'm surprisingly rebellious. I'm sorry. So I just want to ask each of you to share with the audience. What do you think of the AI? Is that going to be real, or it's another bubble?
Well, I mean, people just need to open their phone and start using ChatGPT, and it's real. I mean, it's, but I think it's, you know, I ask everyone, as all the people from Google and so on, were they surprised about ChatGPT capability when it first came out just a year ago? And everybody was surprised, and the people who are deep in AI, even the OpenAI people are surprised, right? So it's real, but I think that progress was a bit maybe unexpected. It came a little bit sooner than people expected, right? So that creates an impression as if it's not here, but you know, in fact, it's here. I think the moment where people feel that they can actually even like have a real sense of what AGI capability, and not just AI anymore, right? People talk about AGI capability and all of that. I think it's real, and I think it's time that we should have serious discussions about, you know, the ramifications of all of this. Yeah. So I think this is really a fitting panel.
Yeah, Professor Valiant in his remarks, you know, briefly alluded to the past strands of AI that sort of didn't succeed. The search paradigm, the logicist paradigm, which seemed at one point the way AI would go. Like when I was a graduate student, these were the dominant paradigms. So now with deep learning and neural nets, it feels different. And I honestly believe, I think that we have hit upon something right. In that sense, it's not a bubble. I don't think this is going to go away and fail like logicism or search failed. Is it a bubble in a different sense? Are we going to at some point encounter another AI winter and feel frustrated? Probably. I mean, that's the way technology works. But I do think that we are on the right track compared to the past, and there's a lot more to come.
Well, certainly I think it's not going to go away. So machine learning is a way of getting information into computers. So traditionally we program computers. This is a second way of getting a lot of information into computers and have them do something which we find useful. So this is obviously a major advance to stay. But I think how we interpret what's happening, I think that's important. And I think there's some danger of giving too much credence to the systems of being human-like and being and solving all the problems. So I think we have to be careful about that. So there could be a winter in the sense as compared to the hype about what people expected to have been solved, which hasn't been solved.
Okay, that's a good answer. Looks like whether we like it or not, AI is here to stay. Maybe our expectation is too high. So given that context, can you please summarize the current state of AI in the whole world? And also talk about what you think for each subfield, who the leaders are.
So let me take a slight variation on what you asked, XD, and that is, see, my focus has been in the last few years, as you know, is how AI can help the global south or AI for development. So not so much about subfield, but in this context, how is AI doing? Is AI going to be helpful for lifting the lives of poor people? And what I'm finding now, increasingly, there's a lot of excitement in countries, LMICs, and it's justified. I think there's a lot of opportunities where AI can help. Just three broad kinds of domains. One is when it comes to tools and devices like automatic reading of X-ray. Already AI outperforms humans for reading lung X-rays for detecting TB and other diseases, and this will only continue to do so. And that will tremendously help places where there are not enough qualified radiologists. The second is system level. Are we able to provide guidance, for example, to farmers through extension programs? We find increasingly that the extension agents are not as knowledgeable, but augmenting them with AI systems like chatbots provides them a greater access to resources and knowledge. And last, population like prediction of disease outbreaks and pandemics. During COVID, we started already seeing how AI modeling was getting very helpful. So I think there is tremendous opportunity for using AI for improving the lives of people.
So I think I think people are still probably thinking about potential ramifications of all the changes that these new AI capabilities will come together with. I guess from the perspective of someone who's in a developing country like Vietnam, I think it's also I mean, to me, it's also quite a personally exciting time as well, because each time there's a moment of acceleration in terms of the rate of growth, right? As XD was showing the graph, it creates both a challenge and an opportunity, right? I mean, the people, for example, in Vietnam or developing country, in order to kind of like make the best on the latch on the new rates of growth, and because of all of these changes and this revolution just came pretty much just a year or two ago, right? So it's an opportunity because we're not behind. We don't feel that we're behind. Everybody is kind of like being surprised by this recent development. So I think it also creates a good opportunity for us to understand about the tech, to make the best use of it, to also think about how to adapt it for the language and the culture of different countries and so on, right? And yeah, really be part of the new revolution in communication. Right? I believe that, like in the future, perhaps I could just speak in Vietnamese, and then you'll be able to listen to it in the language of your own choice. And yeah, but I think in order to do that, I believe that even developing countries like Vietnam will have to try to be part of the game, right? And understand the technology, invest in R&D, and invest in models that perhaps build natively for the language and for the culture.
Thank you. What do you think?
Yeah, so I think machine learning, AI is going to be a great democratizing force in that the value of these AI systems is in the data which they're trained on, and there's an infinite scope for, just like with humans, universities are there to constantly produce teaching materials to train successive generations of students. So in a similar way, I think there's an infinite requirement to train machines with human needs as they arise. And I think every country can join in with problems of interest to them. So I think it's great from that standpoint.
I agree that most of the AI models today are trained with data and web scale. But if you look at the available corpora on the web, English is dominant. So whether it's OpenAI large language model, GPT, or Google's Gemini, or Anthropic, or Meta from the open source Llama, English quality is always better than any other languages available. As I said, there are 7,000 languages spoken on the planet. Also, for many developing nations, there are low resource languages. How can we provide that AI services to serve everyone, every citizen on this planet? Let's take Vietnam as an example. How do we deal with that challenge moving forward?
Yeah, so I think this is a question for Vietnam, so perhaps I could take the first try. I think it's a challenge, it's a difficult question. We have a glimpse of hope, though. The definition of a low resource language, right, that computational linguists came up with, I think it has to do with before, right? When I think about low resource language, I think about language where there's no annotated data set, right? So because it takes time, it takes human effort, it takes organization to create training set with annotation, right? And we're talking about annotation of chunk of languages and so on, and name entity recognition, all of that, right? But now it's for training this foundation model, you don't need annotation, right? And I think that is easier in the sense that, yes, you just need to crawl the web. Of course, you're going to have to do some cleanup of the data, but the data is actually pretty much available on the web. Common Crawl will give you the data. Right? But then there's a trade-off, because in order to process this data, you need powerful machines, right? And the cost sometimes could be prohibitive to smaller teams in developing nations. And I think that's a trade-off, right? By low resource here, then I think the one of the challenge that I think countries like Vietnam have to deal with is we cannot compete with the big companies and also developed nations in terms of computation resources, right? Like Google, OpenAI, Microsoft, and lots of other big companies. They just have way much more resources than countries like Vietnam could actually afford. So I think a challenge is, as you said, I think I was really excited to hear that when XD you mentioned that you managed to get almost the same level of accuracy, but with a tiny a model. It's much smaller, much more efficient to serve. And I think that's also a really important direction that we're pursuing here as well, right? And hopefully the big model will still have its role to play, but you probably can actually solve a lot of task-specific and domain-specific with more compact, more efficient models, and the resource to train, and also especially resource to serve, right? Inference time, inference cost. It's could actually be, so basically the challenge, right, for developing nations, it also becomes opportunities if you actually address that problem head on.
No, I agree with Hung in the sense that it's, the gap, there is a risk that the gap between, high resource countries and languages and poor countries as a result of this can actually increase because of the, lack of availability of data. So it certainly behooves public systems and other leaders in the countries to make special effort to fill that gap. I was in India last week attending an event called the Global Partnerships in AI. And the main buzzword was something called DPI, Digital Public Infrastructure. And I think there's a lot of consciousness that there has to be a more publicly oriented effort to systematically collect data across the languages. And I think, as Hung said, some sense labeled annotation is less of a requirement, which actually makes it easy to do some of the things that were hard to do, but it still requires a systematic effect. And so one aspect of this is just putting in a lot of resources and effort needed to fill the gap in the low resource languages, collecting a lot of spoken data. In fact, one of the challenges is in many poor countries, written method of communication is not the primary, it's really spoken and dialect variations. So you have to collect across all the different regions and such. And the second is actually, what are the use cases? What is it going to be used for? Unless you build a set of solutions that use that data for those use cases, they won't get used. So these things require a certain amount of coordinated investment and effort.
And so I agree completely with that constructing good data sets is an enormous amount of effort. In some sense, at the moment, the big computer companies are using low-hanging fruit, just stuff which is easily available and they think isn't owned by anyone. But in the long run, AI research will consist of putting lots of effort into making good data sets.
So those are really good points. I agree from the purely language point of view, there's an imbalance, between high resource language and the low resource language. But there are other data, such as medical imaging, such as genomic sequencing, right? So those data can be shared for all the nations globally. I personally believe that the fact that the language is so complex, the large language model conquered this is an inflection point for mankind. AI will be a powerful tool to map one sequence to another in an unprecedented way. This impact is going to help AI for discovery on the new material and on science for all fields, including longevity for all of us, fighting cancer. So can you comment, how can we safeguard AI as the most powerful nonlinear mapping sequence ever created on this planet? How do we really make sure AI will not be used to destroy mankind moving forward? Who wants to take this?
Well, my view is that AI is just another powerful technology like chemistry, nuclear physics, which can be used for good and bad. And in each technology, obviously, bad people can do bad stuff and mistakes can be made, or people can take excessive risk, but still, we will collaboratively ensure that, that the risks are mitigated. I don't think there's anything unique about AI in this respect.
I think I agree in the sense that although the hype sometimes makes it look like this technology is different from others and somehow poses greater risk and danger, but the reality is that any technology, even a knife, is a good or a bad thing depending on how you use it. I think there are broadly three ways of preventing damage. One is to some extent regulate the production, making sure that safeguards are put in what tools are actually produced. And there's a lot of discussion in responsible AI and AI ethics. I think that's going to be very important in the industry, being careful about reducing the misinformation and bias. The second actually is regulating the use. I think that's the most important thing. What kind of places where it can be used. You don't let person use a knife to commit murder. So it's in that sense, and then same as any other technology, each domain of civil society will have to regulate it. Right? And the last one is actually to a certain extent policing, watching over who's producing the AI and what is their intention. And I think all three things have already started happening.
I think I asked quite a few people, right, my colleagues and so on, and some of them say that they believe that AGI would be, some of them would actually believe that AGI is potentially attainable within the next 5 years. Of course, depends on who you ask, right? But the fact that even people in AI, right, some serious people in AI actually believe that AGI could come so soon, of course, I think it means that I think a lot of us, and especially people, government, and so on, need to think about this very seriously. For me, I think I have a personal gate, right, where I decide whether we actually achieve AGI. So that I think that there was a challenge. They call it the AI MO challenge, or Artificial Intelligence for Mathematical Olympiad challenge. That was just announced recently within the last few weeks, and I think there was like a really big prize. Be awarded for the first AI to actually get a gold medal in the International Mathematics Olympiad, right? Now, when I was in high school, I could only get a silver medal, right? So even AI actually get a gold medal, that's my personal get. Okay, we've got AGI because it's, I have to say that it's actually smarter than me. But I think I also believe that the model of a human and AI collaboration it's a really great model to push forward. Because I believe that's the future of work as well. Each of us will have a co-pilot, personal assistant, companion that would basically help us to extend our ability and our capability and also our productivity, right? And if we always stay true to that model, then the humans are always in control, right? And I think that's really important. Of course, there's a lot of research needs to be done about how to make sure that humans are always in control, right? But I think that's just going to be a natural progression of the field. Now, of course, I think from the perspective of countries like Vietnam, I think we are less worried about that. I think it's more like, okay, that's a really important question. The developed nations are going to have to tackle that first, obviously, because they will affect developing nations first and foremost. For developing nations, I think it's more of a question of accessibility and being included and not excluded, right? And I think as I said, I think it's really important for people everywhere to really understand this technology. So, for example, we can try to build large language model for particular language, for example, like Vietnamese, right? Going to understand more about Vietnamese and its culture, In fact, at VNI, we build a model called Pho, GPT, and Pho is the famous Vietnamese noodle. We call it Pho GPT. It's also, we made it open source. Right? Again, I think open source is also important because it's going about like helping to cut down the cost of development so that, you know, not everybody can actually have to reinvent the same thing. So I think at the moment, open source is also like a really big, you know, it also has a really big followings in terms of developers and so on when it comes to LLM. So I think I think I have a lot of hope on how we can actually make the best use of this technology.
That's a great summary. Given the time constraint, I would like to move on. Really appreciate this discussion. Thank you. So the next program is to have a special session. We will have
Yes, Doctor. So ladies, please, yes, Doctor, I will assist you with the Q&A session now. So we're coming to the third part of the symposium today with the Q&A session. Ladies and gentlemen, besides offline questions in person, we also have online questions and also the questions and the remarks from our special guest. And now I would love to raise the questions and I would love to invite our special guest to share their opinion and his remarks on the symposium today's topic. Let us welcome Mr. Trương Quốc Hùng, founder and CEO of VinBrain, to raise the questions and share your opinion. Yes, yes, please.
Will you please come to the stage?
Okay.
Yes. You can make your comments standing while we are sitting here, okay?
Okay, thank you, Wesley. Wow, it's great. So this is the third time for VinFuture, and we have a great panel with all the distinguished panelists. So medicine and healthcare touch every people's life. So as a company that building health tech AI for healthcare in Vietnam and the core in Vietnam, VinBrain, we explore into, you know, how to really utilize AI to make the impact. And I think regarding to the question that XD asking about, is you know, a bubble or not? I think at the end of the day, I think technology or AI or anything is bubble or not, probably in my opinion, is the answer about what the impact it brings to the society, to the social impact. So I think that in the context of VinBrain, I can see that when the generative AI come out, we realize that few key things that the ChatGPT or generative AI have bring. One is actually emulate the way the doctor work. And this is the first time in the history that unlike any other AI, the generative AI have bring. For example, the doctor, before they do the diagnosis of a patient, they need to gathering all the information about the textbook, about the lecture, about the research paper, and summarize into their head. Generative AI today can do that. You know, so that's one is aggregated through the text. The second aspect of it is able to really, you know, like pick the right choice for what the option that you can treat this patient. So this option can be like, you know, analyze against the big data set that in their head of how they can, you know, analyze it and bring it together so that they can pick the right pattern to curing the patient. Generative AI today do the same thing by actually looking at the test sentences and pick the right answer for the next word in the sentence. And I think that the last one, I think that the doctor today do more than generative AI can do, is about doctor can have a series of questions to clarify on the patient. And I believe in the future, generative AI and the AI in general can also emulate this fact. So my question today is probably for the panel. It is about the capability of a doctor when they are gathering the information over the history of, like 20 years, 30 years. Maybe in their head, they have a pattern of 20, 50, or 100 patients that have a similar symptom and they classify it. The question in the future is generative AI can help to gathering the knowledge, not only by one brain, which is the best doctor in the world, but really connected of multiple doctors. And that will lead to the room of unwritten rule, how to solve it by connecting the data and bring all the data together. Thank you.
Thank you. Thank you. That's a very, very
Thank
good
you.
question. Thank you. So I want to just make a comment to what Stephen said. There's one example I really want you to think through what this large language model can do today. All of us, after your PhD training, after you get promoted to a professor working in the same field for so long, the amount of paper you read for the whole life is a small fraction of what the large language model read. So their reasoning may not be as good as any of us here, but they have this tremendous memorization capability. The new reasoning is getting better and better. This is why in the US, there was a good example. A patient had this strange disease. The person actually went to see a doctor, multiple doctors. They have no clue to figure it out. Then the mom of that patient asked ChatGPT, describe the whole symptom. Amazingly, ChatGPT suggested a potential rare disease. Then the patient went back to the doctor. Doctor said, oh, that is right. You are right. This was a real story. It was just a concrete example on how AI can help healthcare medicine. And Stephen is working in that. So that is a great question. I would say the large language model can read probably 10 million times more data than all of us combined. That capability is the true power of companion or copilot. So in that scenario, I want to open up for question and answering for the panelists.
Sure, yes. Thank you so much, Dr. Sui Dong Huang. And I think that this is the precious time for us to meet and share the opinions with the top brain of the world. So the audience and delegates, feel free to ask. And so by, yes, raising your hand, yes. So staff, could you assist me with the mic for, yes, for the audience?
Oh, thank you.
Thank you, yes.
This is Laurent Gaoui from Vignuni. I have a question about, let's assume that LLMs are widely used and successful. Inevitably, a lot of the text generated will be AI generated. And inevitably, it will end up in the training sets of those very models. What do you see happening then?
So Dr. Sui Dong Huang, who do you want to address this question for with your panelist?
So I guess
It's like a question for a theoretical computer
Yes.
scientist.
Okay, well, yes, that's something I would worry about, because as I've said, what the system does depends crucially on what the training set is. If somehow you corrode the training set, it'll do something different. So I think one has to be very careful about that. Sure.
So I think I have just something to add to that. I think if you actually change the system using the output of similar system, it probably doesn't add to any new capability, right? The fact that whether it would actually reduce the kind of capability or not, I think there would be ways to ensure that it's not going to do that, right? But I mean, this is my guess, right? That's my bet. But it certainly doesn't add to new capability, and that's the concern, right? So in order to add to new capability, of course, today, one of the main topic is how to add significantly better reasoning capability to model like LLM, right? So that's why I was talking about that there was a challenge, right? To try to get like an LLM to solve IMO problem. Just give it a solution and it spits out a solution, right? And of course, by training on the output of other LLM, it's not going to do that, right? However, there is also notion of agency, right? Each LLM would, communicate with other LLM and also the human being via text, and perhaps there are some interesting behaviors that should come out of that.
Thank you so much, Professor. And I think that we still have one room for questions. And yes, I want to see your hand. Yes, Professor. Now we could see that the hand raising from Professor Vũ Hà Văn, yes, member of the Vinh Future Prize Council from Yale University. Please give a round of applause for Professor Vũ Hà Văn. Thank you for your question.
Thank you. So there was a long discussion about safeguarding AI, and we sort of agree that it depends on whose hand or who is using it, right? So we make sure that only the good guys using AI for good purposes. And I believe in that. But like 5 days ago, I read an article from Nature reporting that AI make a step in solving a research math problem, not IMO, it's a research math problem like people like Terence Tao and me was working on. And then it makes some new step, I mean small but new step, and people analyze it and they say that it came up with some idea that we didn't know before, right? So the expert in the field say that we didn't know this idea. And the AI, Fun Search, is the name of the program, came up with that idea. So now we turn back to that situation now that, okay, the good guy controlling it or the bad guy controlling it. What if AI came up with a new idea that he doesn't like somebody controlling him or her for that matter? So what do you think about this kind of
great question? I would say, Professor, you can probably comment.
I'm not sure whether I understood all the subtleties there. So you can certainly use these AI systems to give you options, different ideas, and then you choose which one you like best. If in your scenario you think that there's a bad guy who's got some special access to a special machine, I'm not quite sure what your scenario is, but then certainly this bad guy can generate for himself.
My scenario is the bad guy, it's the machine.
Is to give us to keep control to the machine. Okay, well then, okay, so then my answer is that obviously, one shouldn't confuse, say, intelligence with control. So we shouldn't give control to machines whose benevolence to us we don't have reason to be confident in. So we should maintain control to parties whom we trust.
Actually, I have a slight variation of what Professor Van Boo said, which is, I think that we probably are already reaching a time where we tend not to challenge what the AI tells us and believe it blindly. I think that there is a greater risk in getting used to it, and so when it makes mistakes, either intentionally or otherwise, we may not actually notice it. I don't know the answer to solving the problems, and to many extent, I think this kind of misinformation-based activity and belief already, exists in society, and the AI is not going to make it any easier. But I do think that there is a risk that as much as we want to regulate it and control it, we might have a tendency to believe it too easily.
Thank you so much, Professor Anandan. Thank you, Professor Leslie Valiant. And don't forget that we still have the private networking discussion right after this session. So don't forget to join. And now I think luckily that we have still one spot left for the last question of this session today. Yes, Gentlemen, sure.
Okay,
Please.
thank you very much for all of you joining this very important event. I highly appreciate the Future Prize, and I would think it can replace the Nobel Prize in the future. And my question related to the change of AI, not just only in everything, for example, in physical world, but also in maybe surgical or maybe about the spiritual world. So now we can have not just only one dimension between the space and time. We have a four scenario, the scenario of relationship between the space and time, according to the philosophical aspects. The first scenario is the interrelation between the virtual space and real time. The second one is the virtual space and virtual time. The third one, the real space and virtual time. And the last one, the virtual or the real space and real time. But now, when we standing in front of the four scenario of relationship between the space and time, how we can deal with? That means we can change everything. That means we can change every action. So we can live in the chaotic world. We cannot get regular or regulation as normal. But how we can deal with this the chaotic world in the future? Okay? Do you understand what I mean?
Thank
You
you,
don't
gentlemen.
understand.
Don't understand it? Maybe the change the relationship between the space and time. This is one of the most basic relationship in the philosophical point of view. So now we can see that the virtual space and real time, for example, ChatGPT use the relationships, the virtual space and real time, they earn a lot of money. But VinFast, just only based on the physical world and physical time, they get not much money because it's based on maybe one dimension or the same dimension. They try to change the dimension between the virtual and real. So I think it can make a lot of money. We can get the exponential pace of growth rate. Okay? Do you understand it? No? Okay. Thank you very much.
Thank you, gentlemen. All the panelists here can get your idea.
Okay.
Sure.
I'm not sure I fully understood the question, honestly, because it was a long question and complex, but I think I'm going to interpret it as about the illusions that are created by using this and how are we going to react to it and manage to it. In other words, I mean, the answer is, we still are what we are. I think this happens even today. My point is a lot of these things that we are thinking about is happening even without AI. Misinformation, living in a virtual world, believing something or the other. I think we will use the same defense mechanisms that we have. I just think that we have enough of a diversity of people that we're going to disagree, and hopefully within that disagreement we will find a common answer.
Thank you so much, Professor Anandan. And with his answer, the symposium today is coming to an end. Once again, thank you so much for all of your questions, your hand raising to raise your questions. And don't forget to write down all the questions so that we can collect it and send it to the panelists today. Thank you so much once again. Thank you, moderator, the chair of the panelists today, Professor Dr. Sui-Dong Huang, and also our distinguished panelists. Thank you so much one more time for your attendance and your support with Vin Future Prize 2023. And now it's time for the breakout session for the audience and panelists. And we also have a private networking Zoom, so that with 3 different rooms for 3 assigned topics. So you can join, and the session will last for 1 hour and close at 15:45 right now after this symposium. Thank you so much. And once again, don't forget that the Vin Future Prize Award ceremony premiered on VTV1 tomorrow, the 20th December 2023. Stay tuned. Thank you so much and goodbye for now. We love you all. Thank you.